Hello, calculus fans. All right, so let's let R be the region enclosed by the curves x equals 1 minus the quantity y minus 1 squared and the y-axis. We're going to take that region and revolve it about the x-axis to obtain a solid. And let's find the volume of this solid. Now, how do we know what this graph really looks like? So let's start with an ordinary parabola x equals y squared, which opens in the positive x direction, and we'll make some shifts and reflections. Now, you don't want to be freaked out by this parabola. It's really not any different than the ordinary parabola that you're used to seeing, which is y equals x squared. It's just it opens in a different direction. But it's really still an ordinary parabola. So we start with that ordinary parabola and reflect about the y-axis. That's going to give us x equals minus y squared. Then we're going to shift 1 unit in the positive y direction. If we do that, then we have to replace the y with a y minus 1. And then we're going to shift 1 unit in the positive x direction. So we'll tack on a plus 1. All right, so let's take a look at the picture. So we've reflected about the y-axis, and then we've shifted 1 unit to the right and 1 unit up. We're going to take that region and revolve it around the x-axis to generate a solid. We're going to use the shell method because we're slicing this thing parallel to the axis of revolution. That gives us delta y slices. All right, so now the radius of the shell is y because that's the distance from the axis to the slice. And then the height of the slice is just x, and that's equal to 1 minus the quantity y minus 1 squared. So now we can write down our delta v. Delta v is 2 pi times the radius times the height times the thickness. And in this case, the thickness is a delta y. Okay, so if we work all that out, we end up with a 2 pi times y times 2y minus y squared times delta y. We're going to need those y-intercepts to get our limits of integration. So we'll set x equal to 0 and solve for y. So we get 0 is equal to 1 minus y minus 1 squared. So that makes y minus 1 squared equal to 1. Y minus 1 is equal to plus or minus 1. And that gives us our values of y, which are going to be 0 and 2. All right, so those values are going to be our limits of integration, so we're ready now to compute the volume. So the volume is the integral from 0 to 2 of 2 pi times the radius times the height times the thickness. Pull out the 2 pi, distribute the y, and we get an easy integral. So we're going to go from 0 to 2 of 2y squared minus y cubed, and that's easy to work out. We're very happy to have 0 as a lower limit of integration. So we just plug in the 2, and we end up with a final answer of 8 pi over 3. Now you try this with the washer method. Not so easy. You could do it with the washer method, and you'll be able to calculate it. The integral will be messier, though. So in this case, I think it's going to work out much nicer with the shell method. Okay, that's all for now.